Welcome to our YouTube video on understanding semaphores. In the world of concurrent programming, synchronization is crucial. And one powerful tool in achieving synchronization is the semaphore. So, what exactly is a semaphore? Think of it as a traffic controller at a busy intersection. Just as a traffic controller manages the flow of vehicles, a semaphore manages the flow of processes or threads in a computer system. Semaphores provide two fundamental operations: wait and signal. When a process wants to access a shared resource, it must first perform a wait operation. This decreases the semaphore count. If the count reaches 0, the process is blocked until another process signals that the resource is available. The signal operation increments the semaphore count, indicating that the resource is now available. If any processes were waiting, one of them is unblocked and allowed to proceed. Semaphores are incredibly versatile and find applications in various scenarios. They are used to implement critical sections, manage access to shared resources like memory or I/O devices, and coordinate activities among multiple processes or threads. There are two main types of semaphores: binary and counting. Binary semaphores have two states, typically used for mutual exclusion. Counting semaphores can take values greater than 1, allowing multiple processes to access a resource concurrently. While semaphores offer powerful synchronization capabilities, they come with their own set of advantages and disadvantages. From ensuring process synchronization and resource management to dealing with performance overhead and potential deadlock situations. Understanding semaphores is crucial for effective concurrent programming. In conclusion, semaphores play a vital role in concurrent programming, providing a robust mechanism for synchronization. By understanding how semaphores work and their applications, developers can write efficient and reliable concurrent software. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more content on computer science and programming topics. And remember, keep coding and keep learning.